Howdy, my name is Dustin Kirkland. I'm from Austin, Texas, and I work for Canonical on Ubuntu. I was invited here by Matt and the team to talk a little bit about ZFS and related utilities as you might find them in Ubuntu. So first off, I want to pose this question, and I'd like you to think about this for the next few minutes while I talk about a few other things. But I'd like you to think about what are the three things, for the Linux users in the room. I understand not everyone here is a Linux user, but for the Linux users in this room, what are the three things you miss most from your Solaris or BSD or AIX or other Unix days, okay? Just bake on that one for a little while. So as I said, I'm from Canonical. We're the company behind Ubuntu. Canonical is, it's been around for 12, going on 13 years. We're over 800 employees, and we're in an amazing 48 countries, which is a tremendous distribution for a company that size. Over 80% of us work from home. We have a couple of offices in London, Boston, Austin, and Taipei, Shanghai, and Beijing. But for the most part, we're this sort of vagabond, travel the world, hack on software, and live where you want to live. We've been that way since day one. It's one of the core virtues and values of the company. So let me ask you, where might you find Ubuntu today? And it's really a little bit of everywhere. Especially, it's funny. Matt mentioned something like Netflix that was shipping DVDs a few years ago, certainly. Not more than a decade ago. But you look at how many of these organizations, perhaps you're from some of these organizations actually, so many of them have basically developed within the last 5 years. And so many of them have this resource sharing as a core tenet to their business model. And their software underneath them actually aligns quite well with that. So you're talking about ride sharing, Lyft and Uber. You're talking about house sharing, Airbnb, and from that perspective, we're really in this peer-to-peer software and technology age, but it's actually moved into the real world. We're actually sharing our resources more efficiently because of technology. Everywhere you see here, we've got Ubuntu established, and that's some pretty remarkable places, and we're very proud of that. Now, when you find Ubuntu is actually sort of the secret to Ubuntu's success, I would say, as the product manager responsible for it. It's the fact that we release on time, every time, and we've been doing this for 12 years. We're working on our 25th release of Ubuntu 16.10. We'll release next month, October of 2016. We've done that on time, every time, and that track record is pretty remarkable for releasing an entire operating system. Every fourth release of Ubuntu is an LTS release, a long-term support release. Those are the enterprise releases. The developer releases are the ones we release every 6 months, and that's what maybe many of the people in this room might gravitate toward for a desktop or a developer environment, while the organizations on the previous slide certainly focus on the LTSs. And then the other secret to, I'd say, Ubuntu's success is the vast variety of open source packages and software that get released every 6 months on time, every time. That's over 55,000 binaries are built from over 26,000 open source projects. And of course, we're proud to have ZFS as one of those and integrated into the Linux kernel as of 16.04. And we can do that on Quartz containers, in virtual machines, and across a wide array of hardware partners. And that's essentially Ubuntu everywhere on time, every time. We put those into public clouds, Amazon, Google, Azure, of course, SoftLayer, Rackspace, Oracle, Joyent. Across the board, we ensure that Ubuntu is in those clouds. It's working well. It's QA'd. It's tested well. It's up to date and secured. But also in the scale-out private clouds as well. That's the Mesos, the Kubernetes, the Hadoop, the OpenStack, Cloud Foundry. Ubuntu running under those clouds and also in those clouds as a basis. We run on some of the biggest supercomputers in the world, from the IBM Z. This is the Qiana 2, the supercomputer in China, but also and this is coming on extremely strong right now, on internet connected devices, printers, drones, robots. That's Ubuntu across the board, and it's really interesting to see how bringing an open source platform to those devices really stimulates innovation. This slide is only in here because I was told the slides are going to end up on a website somewhere. We want to just make sure everyone knows that we do sell support for Ubuntu. All right, let's come back to that question I posed a few minutes ago. What are the 3 things you miss most from Unix, BSD, Solaris in Linux? Yeah, Control T. Okay. Very nice. What else? Say it louder. Thousands of days of uptime. Yes, indeed. What else? Dtrace. That's a good one. What else? Yes, sir. The kernel debugger. Yes, indeed. Yes, sir. Structured proc. Oh, yes. You know where to find things, right? What else? Yes, sir.
Far less threatening security landscape that enable thousands of days of uptime.
Indeed, indeed. Much smaller scope in many cases. Any others? All right. So it's a bit of a loaded question, but that's actually, that's a product manager's dream, to sit in front of a bunch of smart people and ask them, what do you want to see in a product? And here the product is the OS, the Linux operating system. So that's fantastic. The first one, I would say, you don't miss this anymore because it's actually well integrated into Linux. But that's the concept of containers, right? That's jails, that's zones. And now we see various different types of containers that are part of our everyday experience inside of Linux. Of course, that's Linux containers, LXC, LXD. Everyone is familiar with Docker, and the concept of application containers. We finally have, I think, in Linux a bit of taxonomy, some nomenclature that helps us understand that not all containers are the same containers, right? That Docker has a place, that machine and system containers have a place. And I'll demo that here in a second. The second one you don't miss anymore because we also have, and that's ZFS. That's really advanced file system inside of Linux. We certainly take advantage of ZFS. I'll demo that in a few minutes here. We take advantage of ZFS for all of these things: snapshots, backups, instant start time, the efficient compression and automatic repair, the integrity checking. It's brilliant. It's super useful, and we make use of that every single day. So let's dive into those two in a demo here. And I'm going to flip over. Is that big enough? We're good. Okay, so this is an instance in Amazon in EC2 where I'm listing a Z pool that was automatically created for LXD. LXD is a container hypervisor. It provides system containers. I've also got Docker running here. Let's actually start with Docker. So I'll sudo docker run. I'll need this. And of course, I need an Ubuntu in there, an image. It's because everyone is watching right now. All right. Hot dog. I'm in Docker, and I'm running one single process. That's a process container. We put Docker around a single process. Here I'm running bash, and I can do, bashy type things. I can take a look at a slightly structured proc, and have a poke around. If I exit that container is gone. If I wanted to run some other process, if I run top, I'm running one process inside of a Docker container, and that's the best practice. That's using some of the concepts of jails, wrapping a process and keeping that process separate from the rest of the system. I can drop back into another container and then, apt update and apt install and throw some software inside of that container, right? I think most people are familiar with Docker, and so I'll pause that part of the demo here. And that was a sudo Docker, so I was running that Docker as root. At this point, I'm going to LXC launch an Ubuntu Xennial image. It's going to create dashing bonefish, and if I list, I've now got a dashing bonefish running, and then a second later, I've drawn an IP address here. And if I exec into that, a bash shell, I'm now inside of that container, and if I run ps or ps tree, I see what looks like a machine. Certainly more than a Docker container. It's running sbin init. It's running systemd at the top of that process tree. We forked off a journal. We're running cron and at so that this system, if it stays up, it can do cron things, and it can schedule things to happen later. It's drawn an IP address using DH client. It's actually running an SSH server, so I could, if I had keys exchanged, I could SSH into localhost or come into it from outside. For all practical purposes, this is a virtual machine, except that the kernel is shared with the host, which allows us to run a whole lot of these. Now, also, I would say more importantly, I'm going to split the screen here so that I keep this one up and running. Also, I'm running ZFS underneath this, and that's what allows me to launch lots and lots of these very quickly. I can start 2, 3, 4, I could start 100 of these on this system, and every one of these is taking 2 seconds or so using copy on write clones from ZFS. So if I status, that's not the one I was looking for. List. There we go. It's wrapped a little bit here. Yeah, exactly. So, we really love seeing ZFS underneath LXD. It lets us do some pretty amazing things, including snapshots. So if I want to, I'm going to do an LXC list, and I'm going to take this first one, Grizzly. I'm going to say LXC snapshot. And now if I do an LXC list, I can see I have one snapshot of the absolute Grizzly. And let's pop into absolute Grizzly. And let's just create some havoc, right? So now I have no bin directory. If I exit out of there and I try to come back in and exec bash, clearly that container is hosed, right? Let's imagine something has gone wrong with some service. But if I want to restore that snapshot back to a point before I RMRF'd all of user, I'm back online in a fraction of a second and back into that system, state preserved. I actually can snapshot with, you can actually snapshot with state and store the memory as well. And that's how we live migrate containers from one system to another, by snapshotting and capturing the state of the memory and the CPU registers, and we can seamlessly migrate a container from one to another. ZFS is fantastic for its snapshot capability under LXD here. Matt mentioned IOStat. We do enjoy IOStat here. Watching that from time to time and seeing what goes on. A couple of my colleagues from Canonical are here, Aaron and Colin. You want to wave? Colin wrote a utility that we use in Ubuntu called stressng, which is a way of applying some stress to a system, let's say. And it's a way that he unfurls and attacks some really interesting bugs in and around Linux itself. And so I've got a little cheat sheet here, the command I want to run. Stress ng, looks like a couple of threads. We're going to just start really killing the I/O, the hardware I/O, the writes, reads and writes I/O on this system. And then we can run commands of your choice. Give me a ZFS command that might be interesting here to watch this I/O. Well, that one's running right here.
Outside of the watch, you just run it with full name and a number. After that, it will give you auto refresh.
And a number?
Yeah,
2 seconds? Excellent. Okay, so that's going to fill up that split right there, and we can watch it do its thing, right? So I'm gonna let that go here for a few seconds and flip back over here. One of the things that I heard that we were, pining for from our Unix Solaris days might be, I should show snaps as well. I'll get to that in a second. Might be the concept of dtrace, at least dynamic tracing of the kernel, direct raw access into the kernel. And so I'm pleased to say today that we're actually bringing IOVisor and the BCC tools into Ubuntu. Ubuntu 16.04 shipped with the 4.4 Linux kernel, which is the first of the LTS, the first of the enterprise Linux releases, the first kernel from Red Hat, Ubuntu, or SUSE that includes the Berkeley packet filter and the features that we need from BPF to perform really introspective tracing into the kernel. The user space side of that is something called IOVisor, and it's part of the BCC tools, written by Brendan Gregg at Netflix. See how many times we can mention Netflix in a day, right? So Brendan wrote this set of tools, utilities, that make it a lot easier to build traces to insert into the kernel. And he's shipped a number of interesting tools, a few of which I can demo here. What's really interesting is that we're bringing those tools directly to Ubuntu 16.04, and it gives, in many ways, even deeper introspection than dtrace has ever been able to do. This Berkeley packet filter started as a network raw device access tracing utility, but now there's access into all sorts of interesting places in memory and along the file systems and various drivers. So let's poke at this a little bit. I'm just going to let that keep going. So down here, I will use this opportunity to also introduce a third application, or third container type, which are application containers. So we have a new packaging system in Ubuntu called snaps. A snap is like a deb, but it actually sort of wraps a container around a given application. It's different than Docker in that Docker has its own file system, and every Docker instance has its own copy of the file system. A snap actually uses the same host kernel and the same host file system, but the binary as it runs itself is contained using C groups, using seccomp, and using AppArmor. So it's protected from the rest of the system until you give it certain access outside of that container. Now, BCC and IOVisor and tracing in general requires pretty unlimited access to the kernel, right? So that one's a bit of a different case. But snaps themselves have some really interesting advantages over debs in the way we package software into Ubuntu. The first advantage is that we can very easily bring those older packages bring those newer packages into older Ubuntu at any time, at any pace. We've always had this difficulty with the release cycle of Ubuntu that we were, never more than 6 months out, but in 6 months, some really neat things happen. And of course, over 2 years, some really interesting things happen. So snaps give us an interesting way of Canonical bringing new software into Ubuntu, but more interestingly, any developer anywhere making that software available, and available at their pace as opposed to Ubuntu's pace. So I have installed here a couple of snaps. If I run snap list, I could run snap find and search for other snaps. But BCC snap is installed, and the snap bin is on my is in my path. So anything I type, well, sorry, I don't have to type snap bin, but I'm showing you where that stuff is. But we can see the pool of BCC utilities that are available to us, and these are some really interesting stuff. Most of these need a sudo in front of it, and most of them I'm very new to, and so we're going to look at the help before I get us into trouble with with any particular one. BIO latency is really interesting. It's a block device as a histogram. You know, looking at the latency of that block device. So if I run sudo BIO latency and I need an interval, 2 seconds, and a count, we should see some block device latency coming up, and where that latency is falling from a histogram perspective. Of course, we can let that keep running. We'll fire up another one. What else is interesting? Cache stat. So sudo BCC cache stat. Also an interval and a count. So we'll do 2 and 10 again here. So this will show our cache hits and misses, direct reads and writes, dirty pages. Man, we could go on. File top is a good one. Let's try. Here we go. Okay, and interestingly, we can see our stressor running as well, and what's getting hit, what's getting touched from an IO top perspective or file top perspective. We could look at hard IQs, memleak. I'd actually be interested to see if anyone wants to play with this on an Ubuntu system, and give us some feedback. There's a couple of utilities that are specific to ZFS that's actually built into BCC. So let's have a look at those. So ZFS dist will summarize operational latency. Same 2 arguments, interval and a count. So it looks like most of this is happening in the 32 to 63 microsecond. And then we could also set a breakpoint, a threshold, and we want to see any ZFS operations that are slower than some threshold. So I think it has a default of 10 milliseconds. There we go. Thank you for making this a very busy system, Colin. So we're excited about this. This is a really interesting pool of very low-level utilities. We're taking advantage of some interesting new features in the Linux kernel, and we're bringing this fantastic user space from Brendan directly into the Ubuntu archives through the new snap that we've created for that application. That's it. I'm done. I've got 5 minutes left for questions. So. Oh, I've got 15 minutes for questions. Okay, great. Thank you. Any questions? Yes, sir.
Is BCC only available through Snap right now?
It's only available through Snap right now, and from directly on GitHub. So you can certainly go and git clone it and pull it up. I should give props to Brendan. Brendan here. IOvisor is the name of the project, BCC. It's interesting. I had a meeting at Netflix a few months back, and Brendan was asking how to package this as debs. He's a brilliant kernel developer, in his words, and I quote, "I just hate packaging. I want someone else to just package this for me." And the beauty of a snap is that a snap is a really simple package. It's a tiny little YAML file that explains where things go and what permissions are necessary. And then you run a utility we've created called snapcraft. You run snapcraft on your YAML file, and out the other end comes a .snap file, which is just an archive. It's a really simple little tarball, little archive. I should mention that the backend snapd is actually available on basically all Linux operating systems. It makes use of systemd, of cgroups, seccomp, AppArmor, to sort of piece things together. I'd certainly encourage you to try this out and let us know what you think. Very soon you'll be able to just run snap install BCC on any Ubuntu 16.04 system, and you'd have it. It's an alternative to apt install some software. 16.04 ships with snapd installed and no snaps at first, but you can snap find and install software that way. Yes, sir.
So you showed some really great stuff that you can do using BCC tools that people have already developed, but can you do dynamic tracing where you go like, oh, I need to see, can you create new things on the fly basically, not actually go really run the turn?
Right, so that question is directed to me. Can Dustin do that? Not yet, but can you do that? And the answer is yes, absolutely. This is back to the GitHub page, but it explains that the BCC is the compiler. It's a compiler collection. He's shipped a number of interesting things, but you can drop in your own tracing, and it's super dynamic, super interesting, and this goes through a bit of how it works and where it works. We're really excited about this from a developer standpoint. It's hard to get deeper into the kernel today than BPF, and having this collection of the user space utilities is exactly what you need to build those. Matt.
You asked the audience what would make Linux better, essentially. Let me turn the question around and ask you, what would make ZFS better for your customers and your users?
That's a great question. So I'll tell you, one itch that I'd like to scratch is around the live migration of those LXD instances. So LXD is the daemon that watches all the containers on the system. So we've got a bunch of them. We've got a bunch of them running here. I've got 5 of them. LXD itself is a REST API, or has a REST API, and I could literally type LXC move dashing bonefish to some other host, : if I've exchanged the SSL certificates properly, and then this instance gets snapshot, moved, restarted, and then deleted at the source, okay? The slowest part of that operation is actually in moving the underlying file system, okay? Now, we're using ZFS by default, and we love that locally for really fast snapshots, okay? As it turns out, all 4 of these machines have precisely identical starting point. The Ubuntu 16.04 starting point is exactly identical. And in fact, it's probably already over there on that other system. And whether it's a couple of megabytes or a couple of 100 megabytes, I'd like to not have to rsync or copy, it's a file copy, stream straight over the network, encrypted. I'd like to not have to move that 200 megabyte base image over there. I'd rather refer to it by a reference and say, hey, start with the Ubuntu 16.04 image over there, and then run on top of that. We can do that with overlay FS. But with overlay, we don't get all the things we love about ZFS. So I would love for ZFS to have, super high level, but to have some way of solving that, where I could refer to a blob, almost an object, by signature, and wholesale move that thing over somewhere else, and just refer to it, and then stack on top of that from a cloning and snapshot perspective. I'm sure I've used none of the right terminology at your level of the file system, but do you understand what I'm trying to solve here?
I think that's mostly the right terminology, and ZFS send and receive will let you do what you are asking for set up just right for where like the snapshots are the same signatures and you've installed it, like there's a bunch of asterisks there.
Mm-hmm.
Which, we would probably need to work together on like if you can make those true. If not, what can we do in ZFS to be able to like detect that it's basically the same thing or something like that?
Yeah, okay, interesting. So there's a second part, I'll get that question in a second. There's a second part to that, and there's a second place where I would love to see us use ZFS, but we can't today, and that's in snaps and snappy Ubuntu. So we have this other version of Ubuntu that we're working on right now called Ubuntu Core. It's a transactionally updated, read-only, immutable operating system. So your root file system can't change. When you do change it, you're upgrading it, and then we just splat a whole nother copy of /root on top of that, okay? There is read-write space, and that's where applications live, and each application has their own bit of read-write space where they can read and write. We flip-flop back and forth. We can flip-flop back and forth between any version of the OS that we have a copy of. We can flip-flop back and forth between any version of the applications that are installed as well. We currently use SquashFS in those cases, mainly to meet all of the requirements we have around producing an image of Ubuntu, perhaps preload it with some configuration and some applications, and that image has to be usable in public clouds, ingestible into Amazon and AWS and all the different clouds, but it also has to be DDable straight to a little bit of flash media, because this thing is what goes inside of a drone. And right now we're using SquashFS to solve that sort of collection of problems, right? In my head, though, ZFS would provide some really nice, the snapshot aspects and the copy on write would provide some really nice advantages for the wholesale upgrade of the OS, for the rolling back and forward applications as well. It's a little bit related to the previous one, but we're a little bit myopic in that the operating system is what we care about. Is another question?
Not exactly a question, just kind of expanding on the whole replication issue. That's kind of where I live and breathe CFS right now, and ultimately your only challenge there is making sure that it's kind of facile to say, okay, so it's the same on both ends. We start out with 1604 base image, but if it's the same like at an actual file system block level, ZFS does exactly what you want.
Hmm.
If you want a very high-level overview, I wrote a tool called Syncoid that really simplifies ZFS replication, and you can just kind of see, all right, this does what I want, and basically it boils down to first, you have to have that block-to-block identical copy on both ends.
Right.
If you got that, the incremental is just like that, but the key is it can't just sort of kind of be the same on both ends. You have to start out with the
Exact thing on
same
both ends.
binary copy snapshot.
That makes sense. So right now, I think we're starting with a tarball, which is a layer higher in the stack. But if we started out with the block layer on both ends, then we can make that migration much faster. You're
Yeah,
saying.
and another way that you can target that is if you're willing to accept, okay, the first time I do this, it's going to be a full, all the blocks go over the wire like it would be with an rsync with a blank target. If you can accept that, then you don't really have a problem. Like that's what Syncoid already does. If you don't have anything on the other end yet, it moves all the blocks over with full ZFS in. If you do have something there on the other end, it sees that and does an incremental. And you can use, whether it's Syncoid or not, when you do ZFS replication, even if it's like an 8 terabyte VM image, if you only change
Right.
a few hundred megs,
Right.
then it's over like that.
It's exactly what we do when we live migrate
If
things.
you are using rsync right now, you can literally just replace rsync with like Syncoid as a wrapper.
Syncoid. Okay.
You'll probably want to go further than that, because Syncoid really just boils down. It's a Perl script that orchestrates the actual ZFS send and ZFS receive replication. It might be a really good starting point to look at, because basically, like I said, if you're using rsync now, you can just say, okay, well, no more rsync, instead we can use
Right.
and kind of go from there, and then you'll probably want to boil it down to something that's more specific to what you're really trying to do.
Good. So I'll certainly get a good debrief from you and take a look at it. The two developers at Canonical focused on LXD are Stefan Graber and Tycho Anderson. Neither of them are here this week, but I'll certainly bring that back to them. Thank you. Yes, sir.
Integration you've shown with ZFS in LXC, something that's available
Yes, absolutely. So I set this up ahead of time, so I didn't. The question was the setup of ZFS for LXD and if this is available in 1604. So a couple of things. First of all, the ZFS kernel object is part of the Ubuntu kernel now. We build that out of tree. We'll build that into the tree. Colin and Aaron here are largely responsible for that. The utilities, the ZFS Linux utilities, is a package that we've also brought into Ubuntu as well. Aaron's responsible for that package and works with the Debian community to try to keep those two in sync. The integration of ZFS and LXD together is automated by a script that we wrote called ZFS init. LXD init. And I already ran that on this machine, so I'll need to find another place to... It comes along with LXD itself. So apt install LXD. Apt install LXD. Actually, LXD ships as part of Ubuntu. Apt install ZFS will bring the user space utilities. The kernel piece is there. The user space utilities is one command away. We're actually working on bringing that into the default image. Right now, this is technical detail, but right now ZFS Linux utilities depends on Python 2.7. We've done a lot of work to take Python 2 out of the default image, so we're just trying to make sure that those Python utilities still work with Python 3, or we move them out or fix them and upgrade them. As soon as we've got that, and ZFS only depends on Python 3, we can bring the ZFS package into the default instance, at which point LXD and ZFS are just there by default always. The one thing that you have to do to make LXD and ZFS work well together is sudo LXD init. Running that command will prompt you with a couple of interactive questions. Hitting enter will do the right thing, but it'll ask you, I'm trying to think how quickly I could get this set up somewhere. I'll demo it for you later, but basically it'll ask you, do you want to use ZFS or a directory for LXD? And you type ZFS, which is the default. Then it'll say, do you want to use a block device, or do you want to use a sparse file, or just a backing file? And the default's a backing file because that's safe and we can do that everywhere. For the demos that I'm doing here and almost anywhere I set this up, I always use just a raw SSD as the backing device for ZFS. But by default, we'll create a 10 or 20 gig sparse file, and then essentially block mount, loop mount that file, and then create a Z-pool on top of that block file. Which has a few limitations, but generally works well in the nominal case. After that, your storage is done, and then it asks a bunch of network questions. Do you want to use an existing bridge? Do you want to NAT out to the network? Do you want to use IPv4 and IPv6, or one or the other? It's a really neat little interactive utility. Yes, if you've already got a ZFS pool, you can just tell it to use that existing pool. I doubt I'll be able to start an instance in time, but the sudo LXD init, and you'll see all the questions. It's a nice little set of questions. So, I'm told I'm out of time. This was fantastic. Thank you all for ZFS, and thanks for listening.